This lesson will focus on solving quadratic equations using the zero product property. Let's define a quadratic equation. It is an equation of the form ax squared plus bx plus c equals 0, where a is not 0. Just think about that for a moment. If a was 0, then this quadratic term would be 0, leaving us just a linear equation. Hence the stipulation that a cannot be 0. This form is called the standard form of a quadratic equation. A quadratic equation can also be called a second degree equation because the degree, or the highest exponent, is 2. We're going to use a property from real numbers that will enable us to solve a quadratic equation, and that property is called the zero product property. It states that if m times n is equal to 0, then either m equals 0 or n equals 0. Think about an example of real numbers. If I tell you that two numbers multiply to be 0, what must be true about one of those numbers? Well, one of them has to be 0. The only way for a product to be 0 is if one of those numbers is 0. 5 times 0 is 0. 0 times negative 10 is 0. So that's all this property states, is that if the product of two factors is 0, then at least one factor is 0. How will that relate to quadratics? Well, if you remember, a quadratic expression can be factored, that is expressed as a product. So it might be that we have a quadratic expression, and let's just say we end up with something in the form x plus 3 times x minus 5 is equal to 0. Applying this property says that if those two factors have a product of 0, then at least one of them has to be 0. So that is that either x plus 3 is equal to 0 or x minus 5 is equal to 0. We can solve those equations. Those are linear equations, subtracting 3 from each side to give x equals negative 3, or adding 5 to get x equals 5. Remember, the whole goal of solving an equation is to find the values of the variable that will make the equation true. So we're going to go through and apply processes that give us simpler forms of that equation so that we can apply this property of zero products to give us the values of x that will make the equation true. So let's look at some examples. The first example is to solve x times 2x plus 1 equals 15. This equation is not in the form for us to apply the zero product property. To be in that form, we first have to have an equation that's in standard form, ax squared plus bx plus c equals 0, and then we have to factor that quadratic. So we have to have our equation in something times something equals 0, and then we can set each factor equal to 0. To solve this equation, we have to undo the multiplication and put it in a form where 0 is on one side. Distributing gives us 2x squared plus x equals 15. To get one side of the equation equal to 0, we will subtract 15 from each side. This gives us 2x squared plus x minus 15 equals 0. We have a trinomial on the left that we need to factor. We can factor that by trial and error or the AC method. If I do the AC method, I'm looking at 2 times negative 15 is negative 30. And I need to find the factors of negative 30 whose sum is the middle coefficient, or 1. If I think about the factors of 30, let's ignore the signs for just a moment. 1 and 30, 2 and 15, 3 and 10, 5 and 6. Because the product is negative, the factors have to be different signs, but the sum is positive, so the larger factor needs to be positive and the smaller one negative. And the only combination that will give us a sum of 1 is negative 5 times 6. So we replace the 1x with negative 5x plus 6x, and then minus 15 equals 0. Factoring now by grouping the first two and last two terms. 2x squared minus 5x has a common factor of x. Factoring that out leaves 2x minus 5. The terms 6x and 15 have a 3 in common, so we factor out a positive 3, leaving 2x minus 5. And then set that to 0. We now have a common binomial factor of 2x minus 5. So our factorization is 2x minus 5 times x plus 3 equals 0. Now we have this equation in the form where the zero product property can apply. We have a product equal to 0. The only way that's true is if one of those factors is 0. We set 2x minus 5 equal to 0, or x plus 3 equal to 0. Solving each of those, we can add 5 to each side to get 2x equals 5, and then divide by 2 to get 5 halves, or subtract 3 from each side to get x equals negative 3. So the solution set is negative 3, comma 5 halves. We typically write the solutions in order from smallest to largest, though there really is no order in a set, so either way you write them will be correct, but just kind of standard form to do that. Now what do these solutions mean? If I took the time to plug in negative 3 in place of x, I'm going to see that that product that results there is 15. I'll also find out that to be the case if x is 5 halves. One really cool thing is that the degree of an equation tells you the number of solutions. This degree being 2 tells us we're going to have 2 solutions of the equation. Example 2 is to solve 24x squared equals 8x. Again, we need to put this in the form that will enable us to apply the property. We first have to subtract 8x from each side to get 24x squared minus 8x equals 0. This is a binomial. We just need to first look for a common factor. Between 24x squared and 8x, a common factor is 8x. Factoring out 8x gives us 3x minus 1, or 8x times 3x minus 1 equals 0. Now we have a product equal to 0. We set each of those factors equal to 0. So 8x equals 0 or 3x minus 1 equals 0. Solving, be very careful here. 8x equals 0. We divide by 8, right, because that's a coefficient, not a term that's added. We get x to be 0, or we add 1 to get 3x equals 1, and divide by 3 to get 1/3. The solution set is 0, 1/3. So in summary, to solve a quadratic equation by the zero product property, write the equation in standard form, factor the quadratic expression, and then set each factor equal to 0. We will find that factoring does not solve every quadratic equation because not every quadratic expression factors. So we need to introduce other methods whereby we can solve quadratic equations. Look for other videos on those different methods.